Eric Burgess here, and we've been given the following equation. The absolute value of 12 minus 6x plus 3, so that's outside the absolute value, is greater than or equal to 9. So they want us to solve this thing, so let's just go ahead and first isolate the absolute value. It's always a good idea. So we do that by simply subtracting 3 to both sides. We're going to get 12 minus 6x is greater than or equal to 6. Right? Because 9 minus 3 is 6 and 3 minus 3 is 0. So once we're here, we need to figure out what values will make this true. So we want to be greater than 6. And the absolute value will turn all the negative numbers positive. So for example, if we had negative 7, it would become positive 7. And 7 is greater than 6. So numbers like negative 7, negative 8, negative 9, they're all cool because they're going to become positive and they're all bigger than 6. And it's also true for numbers that are already positive. Like for example, 7's greater than 6, 8's greater than 6, 9's greater than 6. So we can say two things. 12 minus 6x, right? We want this to be greater than or equal to 6. And that's just true because if we had like 7, it's greater than 6. That's exactly what we want. Now we also want this. 12 minus 6x. We want it to be less than or equal to negative 6, right? Because if we had like negative 7, that's less than negative 6. And so that would make this one true. And it would also make this thing in here, when we get negative 7, it would become positive, and that would also make this bigger one true. So this is the second equality that we want. And of course, you could remember the rule that you simply flip the signs of the inequality, the direction, and you change the sign. And so there's that rule as well. So this one we left it alone and just kind of wrote it as is. This one we flipped the sign, but we also flipped the inequality. So, all right, from here we can solve the two intervals that we've set up. So first I'm going to subtract 12 to both sides. So I'm going to get negative 6x greater than or equal to negative 6. We're going to divide by a negative, which will flip the inequality. So dividing by negative 6, we get 1. Now on this side, we're going to do the same thing. We're going to subtract 12. So we're going to get negative 6x less than or equal to negative 18. And then we're going to divide by negative 6. Since we're dividing by a negative, it'll flip the inequality. We'll get x greater than or equal to positive 3. Cool. So we have two intervals. And let's go ahead and graph these. It's a good idea to do so. So I'm going to graph the one side in red. So x must be less than or equal to 1. So let's just put down a 1 right here. The 1 is included because of this equal sign. So we're going to have a bracket. And we want x to always be less than it. So this would be the interval for that side. Now this side says that x, I'll do this one in green. So we've got a 3. I'll just put 3 down. X has to be greater than or equal to 3. So it's included because of the equal. So we use a bracket. And then it's got to be greater than 3. And on this side is positive infinity, and on this side is negative infinity. So we say that x has to be in one of these two intervals. So it can be in the interval from negative infinity to 1, or the interval from 3 to infinity. And we can check these intervals. And since these are included, we should check our endpoints as well. So we can check the number 1, and we would expect to get out 9 when we plug it in. So let's try that out. So we're going to do 1. So 6 times 1 is negative 6, right? Because this is a negative right here. So we have negative 6. 12 minus 6 is 6. And 6 plus 3 is 9. And we get 9 equals 9. So this endpoint checks out. Next up, we need to check this endpoint, 3. So we do 3 times 6. Now this is a negative 6. So we get negative 18. 12 minus 18 is negative 6. Negative 6 absolute value is 6 plus 3 is 9. So this endpoint also checks out. Next up, we need to check inside the intervals and ensure that, we didn't make a mistake and oopsie and go the wrong direction. So let's pick a number in here. Let's pick negative 2. So negative 2 is in this interval, or in fact 0. 0 is even easier. So 0 is in this interval. So we're going to pick 0. 6 times 0 is 0. Absolute value of 12 is 12. Plus 3 is 15. 15 is greater than 9. So this interval checks out, or at least that one number in the interval checks out, which gives us confidence that the other numbers will check out because we followed all the rules of algebra. We didn't make any silly mistakes. So over here, we need to check something. Let's check 5. Why not? Or let's check 4, because 4 is in the interval. So we're going to have 6 times 4. That's 24. It's negative because of this negative sign. So negative 24. 12 minus 24 is negative 12. Absolute value is going to be positive 12 plus 3 is 15, which is also greater than 9. So this interval appears to also check out. We didn't make any silly mistakes up here in our algebra. And so this appears to be the correct solution set. So what we're going to do is we're going to write that out. And so we're going to say x is an element of, and if you're doing this online, they're going to use the brackets for intervals. So there's also a set notation version. I'll write them both out, but online won't accept the set notation version. So what we're saying is there's an interval, and in here we've got from negative infinity. So we're starting at negative infinity. We're going to 1, and we're including it. And we're going to union that with 3. We're including that to infinity. And infinities always get brackets or parentheses. Infinities always get parentheses because you can't ever get to infinity. So you can't ever really include it. And then we would close this. So the other way to write it is with set notation. However, the computer doesn't like this version, but when written and like a human reads it, it's obvious that this is an interval. So you wouldn't need to worry about like it being marked wrong or something, but this is the one the computer wants usually. And depending on how your professor writes it, they may not even care if you write it in this formal notation. You could just write out this bit in the middle and say that, you know, X has got to be in there, and that would be good enough for a lot of professors. So there you go. If you have any questions about this, let me know. Subscribe and hit that bell icon for future videos. If you're a Citrus College student, we've got online tutoring. You should totally swing by. We are there to help you out, and we'll catch you in the next problem.